Who has an answer? Brandon? Nope. Nope. Zach? What? 3.8. I want it in fraction form, not mixed number, improper fraction form. Improper. It's not wrong, but it's not exactly what I want. No. Caleb? Yeah. Y equal negative x plus 19 over 5. Okay, we want the x first. Okay. The other thing is when we're dealing with all of these types of functions, and when we start talking about slope-intercept form, things of that nature, we always want to just leave our answer as an improper fraction or a proper fraction. Okay. The reason being is because when we get into slope and things like that, it'll start showing why you want to leave it as an improper fraction or just a proper fraction. How you get that answer is, first of all, we're trying to get y by itself. So we've got to take the 5x over here. Here it was a positive. Here it becomes a negative. And so that gives me 5y is equal to negative 5x plus 19. Obviously, we can't put those two things together because they're not the same or similar terms. So therefore, I'm left with the 5. I've got to divide by 5 to each of the terms. This cancels, leaving me with y. This cancels, leaving me with negative x plus 19 over 5. And that's your answer. Okay. Let's look at this one. 1/2 x plus 5 over 2y equal 1. Now, I'm going to take and do this. I'm going to take this over here. So that gives me a positive here, a negative on this side. So that gives me 5 over 2y equal negative 1/2 x plus 1. Okay, now to simplify that, I've got to multiply everything by 2 over 5. Okay, so let me rewrite that step and make sure everybody understands this cancels. And that leaves me with y equal 2/5 times negative 1/2 x plus 2/5 times 1. Okay, now here the 2's cancel, so that leaves me with y is equal to negative 1/5 x plus 2/5. Okay, once again, both of these answers is step 2. Okay, of the 3 steps, this is step 2. Okay, now, let's look at 37. Number 37 gives us y is equal to negative 2x plus 5. So is that already in function form? Yeah, it's already in function form. Okay, so I don't have to do step 1 or 2 because it's already there. So all I've got to do is come up with a table of values. Okay, that's all I have to do for this problem. So, once again, we're going to use x and y, -1, 0, 1. Okay, on these, it's not going to matter as much on the table of values as it did yesterday. Okay, the reason being is because I'm just trying to come up with 3 points that I can plot on a line plot on a coordinate plane to come up with my line. Okay, so y equal -2 times -1 plus 5. Okay, all I did is I took this value and plugged it in right there for this x. Okay, now that gives me y is equal to 2 plus 5, which is y equal what? 7. Thank you. Wow, I didn't realize it was going to take that long. Okay, so that's my output value when my input value is -1. Okay, the next one is y equal -2 times 0 plus 5. So y is equal to 5. Because -2 times 0 is 0. Last time I checked. Then the next one is y is equal to -2 times 1 plus 5. Y is equal to 3. Okay, the reason it is 3 is because -2 times 1 is -2. -2 plus 5 is 3. Who is it? Open it up. All right, now, so our ordered pair is -1 and 7, 0 and 5, 1 and 3. Okay? We have to graph that. Okay, so we have to graph those points. Okay, so we have 0 and 5. So 0 and 5 would be 0, 1, 2, 3, 4. Oops, I'm going to have to move it down, figures. I thought I made it big enough, but I didn't. See, 0, 5, 7, and 3, so I can get away with this right here. I can get away with that right there by looking at my numbers. So, -1 and 7. -1 is here. 7 is 1, 2, 3, 4, 5, 6, 7. So that's -1 and 7. Then I have 0 and 5. 1, 2, 3, 4, 5. Then I have 1 and 3. So 1, 1, 2, 3. Okay, and so there is my line. Yep. What do you mean graph it by odd numbers? Okay, you're still not making any sense. Because there's odd negative numbers, there's odd positive numbers, okay. So, this part right here is the actual answer. Okay, because they've asked us to graph, come up with a table of values, then to graph it. Understand that I could have come up with any values, but the line is going to look very similar to that. Okay? And I don't care if you draw your graph like we did here. Okay, if you draw your graph like we did here, where we know most of it's up here, there's no reason to draw this humongous graph with all 4 quadrants in it if all our points are in quadrant 1 and 2. Okay, to go counterclockwise. Matt? And Zach? Oh? Larry? X-axis? Would it be in quadrant 1? That's in both. Well, no. Are you asking me if the coordinate is 0? 0 and 5, right here, you're talking about this one? There's just y-axis. There is no quadrant. If they fall on the y-axis, then to list that point in a quadrant, you just put y-axis. If it falls here, then you just put x-axis. Okay? Caleb?
Do you want us to put the ordered pairs up there?
Yeah, it'd probably be good to just you can either put them there or actually put them, with the dots they correspond to, like this. Once you have your line drawn and see that, you obviously you wouldn't want to put the ordered pair 0, -5 right there, obviously. Okay. Yeah, it'd be hard to read there, but yeah, you really need to list them somewhere. This was -1 and 7, and then this is 1 and 3. Okay. So, all right, let's look at another one. I want to look at one with a fraction, okay, because I want to show you what you need to do when you have one with a fraction. Let's look at this one. Y equal -3/4 x plus 1. Now, when you have a fraction in function form, okay, this is what I'm talking about right there. Okay, when you have a fraction in function form, okay, your x values need to be multiples of your denominator. Okay? So, in this case, we want our multiples to be multiples of 4. So our x values need to be, for example, -4, 0, and 4. Okay? Or 0, 4, 8. Okay? Or, 4, 8, 12. The reason why is this. For example, you don't have to write this part down. Let's say I used my x values just like I did before. -1, 0, 1. Okay? Well, if I use these values of -1, 0, 1, and I plug in -1 right here. Okay, well, the problem I'm going to run into is this. -1 times -3/4 is what? +3/4, right? So if I take 3/4 and add 1 to it, now I have 1 3/4. So now I'm having to graph -1 and 1 3/4. Okay? Which is, you can do, but it just makes it easier if we do it the other way with the multiples. Okay? And I'll show you why. So let's not use those, but let's use x equal negative 4, 0, and 4. Okay? Because those are multiples of my denominator. And so here's what you would have then. Now it becomes easier. Y equal negative 3 over 4 times negative 4 plus 1. Well, now the negative 4 and 4 cancel each other out because we can cross cancel. And that leaves me with y is equal to negative 3 plus 1. Oh, yeah, thank you. Would be. Because I forgot that other negatives there. And so y is equal to 4. So when x is equal to negative 4, y is equal to positive 4. Now you move to the next value. Y is equal to negative 3 over 4 times 0 plus 1. And so y is equal to 1. Then you move to y is equal to negative 3/4 times 4 plus 1. Well, once again, the 4's cancel each other out, making that y is equal to negative 3 plus 1, which means y is equal to negative 2. Okay, so our points then are negative 4 and 4, 0 and 1, 4 and negative 2. Now I can draw, see, I've got negative 4 and 4, they're all, so I'm going to have to do a full one. Now, what I'm looking at to see what I have to graph is I'm looking at these points. Okay, 4, 1, and negative 2. So I'm going to start here, 4, and there's going to be a 1, there's going to be a negative 2. So in this case, I need to go ahead and draw both sides of it. Okay, and so now I have negative 4, so 1, 2, 3, 4, and positive 4, so that's 1, 2, 3, 4. So it's right there. Then I have 0 and 1, which would be right there. Then I have 4, negative 2. So 1, 2, 3, 4, 1, 2. Okay, now I connect our dots. Okay, and so that's your point, or that's your line. Now, once again, this was negative 4 and 4. This was 0, 1. And this is 4, negative 2. Now, we didn't get a chance to talk about these yesterday, so I want to go ahead and talk about them today. Okay, let's talk about vertical lines, and let's talk about horizontal lines. Okay, on our vertical lines, each point, let's look at those points. Okay, the coordinates of this point is negative 2 and 4. The coordinate of this point is negative 2 and 3, negative 2 and 2, negative 2 and 1, negative 2 and 0. Okay? So, the equation of that line then is this. X equal negative 2. Okay, that's the equation of that line. So a vertical line is going to be equal to, or going to be X equal something. Okay, that's what a vertical line is going to be. So if you look at 44, X equal 9. Okay, X equal 9 is going to be over here. Okay, that's going to be X equal 9. Wherever, you draw it on a graph, I don't know if that's 9 or not. That's 1, 2, 3, 4, 5, 6, 7, 8. Hey, it was. I guessed right. Okay, that's so that's X equal 9. Now this one down here, our coordinates here, okay, that is X equal, let's see here, 1, 2, negative 2, and Y is equal to negative 2. Because it's 2 down, 1, 2. So this would be X equal negative 1, Y equal negative 2. No, hang on here, that's wrong. That's 3. 3 that way. This is negative 3. This is negative 2. And then this one would be negative 1, negative 2. This would be 0, negative 2. This would be 1, negative 2. So the equation for this one would be Y equal negative 2. Okay, so a horizontal line is Y equal negative 2 or Y equal something. Okay, so in a horizontal line, there is no X value, there is no X in the equation. Okay, for a vertical line, there is no X or no Y in the equation. Okay. Yes, Owen. No, they're just a vertical line could be actually, they could give you a vertical line that looks like that right there, and it doesn't really cross anything. Okay, they could give you a horizontal line that goes like that right there. All right, so it's not going to necessarily cross the x-axis or the y-axis. Usually when they do their vertical lines, it does do that. They usually will cross either, on the vertical line, they'll cross the x-axis, and on a horizontal line, they'll usually cross the y-axis. Okay, now, last thing. One of the harder problems you'll have, or the harder type of problem. Okay, now it's not in function form. So now I've got to do all 3 steps. Okay, I've got to rewrite it in function form. Okay, then I have to find the values, then I have to graph it. Okay, so this one here, I got to take 4x over to the other side. 4y, yes. So here it was a positive, here it becomes a negative. And so that gives me 4y equal negative 4x plus 2. Bless you. Now, I have to divide by 4 to everything. That cancels. That gives me y equal, this cancels, giving me negative x plus 1/2. Okay? So now you got to come up with the values. And unfortunately, you're going to have fractions. Okay? There's nothing I can really do to not have fractions. But the good thing is it's a half. Okay? So I'm just going to use negative 1, 0, and 1.
Even if we use like 2, 0, or negative 2, 0, and 2, we still have fractions?
Yeah, because you're adding. You're not multiplying. So, you can take negative 2 and add a half to it, but you're still going to end up with a half. Okay? So, if we plug in negative 1, that's going to be y is equal to negative 1, which is positive 1. So y is equal to 1 plus a half, which is 1 1/2.
Wait, you only have to use the multiple of that number when you're multiplying,
Right,
right?
yeah. Yeah, you only use the multiple when there's a fraction in front of the x, basically.
So, Coach, do you want us to switch it to, it'll be 1 1/2, do you want to switch it to an improper fraction?
Well, when we're actually graphing them, go ahead and change them to mixed numbers. Yeah, when you're actually graphing them, then we want them in the values to be finalized in 1/2. So that's 1 1/2. This is a half. Okay? And then the next one would be negative. No, it would be negative half. Be negative half because of this. Y equal negative, and there's your 1 plus a half. So that would be negative 1 plus a half, which is negative half. Now, to plot this one, it's real easy. It's a small graph. It's like this right here. Okay, you get negative 1 and 1 1/2, which would be negative 1 would be here. That's negative 1. So negative 1 1/2 would be right there. Then you have 0 1/2, which would be right there. Then you have 1, which is here, and a half, which is there. And then you just draw your line through that. Huh? What's the line for? Graph the equation. You have to have the line because that's the graph. This line is the graph of the equation. Okay? Huh? No, it's a graph of an equation. A graph of an equation is always going to be a line. Anytime you graph an equation, a linear equation, it's going to be a line. Okay? Now, understand that if we didn't start with negative 1, 0, 1, you could use whatever. Okay? In other words, you could have a point out here. This point right here would be negative 2. You could use negative 2. Well, negative 2 point would end up right here. Okay? So you can use negative 2 would end up as 1, 2, 2 1/2. Okay? So that line, no matter what values you use, this line eventually is going to look like this right here. Okay? I'm just giving you the values so all of our lines look similar. Okay? Because it's hard to grade this. I'll be real honest with you. I end up having to grade them. So, huh?
You're grading me?
I end up having to grade it because, you know, to sit there, it'd take us forever to see, and I can tell real quick whether the line is correct or not. Okay, so that's a problem that you had to do all three steps. Step 1, rewrite it in function form. Step 2, come up with the values. Step 3, plot the values and do your line. Okay, because that's the other reason, Zach, we draw a line is because up here yesterday, further, right there, draw a line through the points. That was step 3. Okay? All right, so your homework is this. All right. Now, it is going to be 4.2, and you're going to do 30 through 35 all. Okay? And then we're going to do 36 through 50 even. Okay? These are the graphing ones. Those you have to graph the line. Okay? These you're just rewriting in function form. Okay? I won't make you do any word problems on those. Although eventually we will. Okay? So, that's it. See you on Monday.